Hello everyone, this is the final video in the series of videos on output analysis. Now, given the system x is equal to ax plus b, the question that we're interested in asking is what changes need to be made to the total output when your final demand changes by a certain amount. So here we have, this one is a little bit different from the other two questions that we've seen. Let's think about it. Now, the final demand is now going to change by a certain amount. And so the output will also have to change in order to meet the changed final demand. Now, how will we compute what's going to be the change that needs to happen to the total output? Now, if you recall, when we answered the second question, we figured out that x can be figured out by this formula, 1 minus a inverse times b. Now, we have x here, and we have I minus a inverse. And now, we know that the demand is changing. And if we denote the change by delta D, then the total demand is now going to be the original demand plus the change in demand, right? And when there's a change in demand, the output will also have to change. So we have the original output plus whatever that change is going to be. So delta, the triangle symbol is called delta, and that refers to change. Now, let's keep the left-hand side as it is, and we'll expand the right-hand side. We can write this as I minus a inverse times b plus I minus a inverse times delta b. Now, and we have x plus delta x on the left-hand side. This term is actually just x. So you have x plus I minus a inverse times delta b. So you have an x here and you have another x there, which gets cancelled off. Therefore, you're left with delta x equals I minus a inverse times delta b. So given a particular change in demand and given the technology matrix A, we can compute the change in output that is needed in order to make the changed demand. Now, let's go through an example where we kind of tie in all these ideas together that we've been seeing in the input-output analysis spectrum. Now, we have two industries, I1 and I2. And this particular part of the table actually deals with the flow of inputs between the two industries, right? And then we are given the final demand. So we have the table of inter-industrial flows. And now, assuming that the total output produced by each industry is just sufficient to meet the input and final demand requirements, we are asked to write the total output vector. We are asked to find out the matrix of technical coefficients. And once we have that information, we also want to compute the new total output vector when the final demand for the first product actually rises by 100 units. Now, let's take this question one part at a time. So we have the inter-industrial flow and we have the final demand, and we want to now compute the total output that is being produced. And we are told that the output is enough to meet the input and final demand requirements. Now, let's think about the first industry. So if we focus on the first row here, 200 units of I1 go into producing I1. 300 units of I1 go into producing I2. And then 500 units of I1 now meet the final demand. So the total output of I1 that is produced should be now equal to all of these quantities that I1 needs to meet. So the total amount of output from I1, let's call that x1. That is now just going to be equal to 200 plus 300 plus 500, which gives us 1000. So total units of output from I1 are actually 1000. And similarly, if we want to find out the total amount of output from I2, that that is actually, let's call it x2. And that will be the second row. 100 units towards producing I1, another 100 units towards producing I2, and 300 units in the final demand, which tells us that in total, 500 units of X2 are produced. So we now have the total output vector. X1, X2 is now going to be X1, X2. The matrix X, which is X1, X2, is just given by 1000 and 500. The next part, we're actually asked to find the technology matrix, which is the matrix of technical coefficients. Now, the technology matrix will actually tell you the flow of output between industries in order to produce 1 unit of output in each industry's case. Now, if you think about this particular table, right? If you look at this number 200, you need 200 units of I1 to produce 1000 units of output from I1. You need 300 units of output from I1 in order to produce 500 units of output X2. And then, similarly, you can read each element in that 2 by 2 table. Now, in order to compute the technology matrix, we want to get the idea of how much of input do you need to produce 1 unit of output. So if we think about it, so let me just repeat the elements here. So we have in a different color. So we have 200, 300, 100, and 100. So this is I1, and we have I2. 200, 300, 100, and 100. Now, these are inputs, and these are the outputs. Now, let's look at the column. To produce 1000 units of output of I1, I need 200 units of I1. So to produce 1 unit of I1, I need 200 by 1000 units of I1. Similarly, to produce 1000 units of I1, I need 100 units of I2. Therefore, to produce 1 unit of I1, I need 100 by 1000 units of I2. Similarly, I need 300 units of I1 for 500 units of X2. Therefore, for 1 unit of output from the second industry, we need 300 by 500. And then this will also be 100. So essentially, your technology matrix looks at per unit input requirement. Okay. So this now becomes, you have this is 0.5. I think this will be 0.6. This is 0.1. And this is 0.2. Is that the right matrix? I'm sorry, 200 by 1000 is not 0.5, it's 0.2. And then yes, so you have 0.2, 0.6, 0.1, and 0.2. This is now your technology matrix. So it's the per unit input requirement. Now, once you have A and your final output vector, and you also have your given demand vector, we want to find the change in output when the final demand for I1 goes up by 100 units, and the final demand for I2 does not seem to change because it's not given to us. So we know that delta X is I minus A inverse times delta B. So I minus A is just going to be an identity matrix minus this A. So I'm just going to put 0.8, so B minus 0.6 minus 0.1, and this will be 0.8 again. Inverse of that into delta D. Only the demand for I1 rises by 100 units, so this will be plus 100. And we have the 0. Now let's go ahead and compute the inverse of this particular matrix. So we are going to need the determinant of I minus A. So this will be 0.64 minus 0.06 into the adjoint matrix, which will just be 0.8, 0.8, 0.6, and 0.1. And multiply that with the this will actually be 0.58. And we have, let's take a product here. So 0.8 into 100 will be 80. And then you have a 0 there. And this will be 10. And it's another 0. So we do 1 by 0.58 into 80. So let me just pull up my calculator here to check the answer. So we have 80 by 0.58, which comes out to be about 137.9. And we'll round it up and write it down as 138. And if we do 10 by 58, that is about we have to do 10 by 0.5. Oops. 10 by 0.58. So 10 divided by 0.58 is about 17.24, which rounds up to be 17. So if delta x is 138.17 and x is actually given by 1,500, we want to find the total new output vector, which is just x plus delta x, which gives you 1,138 and 570. So given the change in your demand vector, we have now been able to compute the change in the total output. And this is the total new output. This is the change. Right. So with that, we now wrap up our series of videos on input-output analysis. So thank you for staying with me so far. Good luck with everything.